Hey you guys, I'm going to read out loud to you Marking Period 4, week of May 25th through the 31st, Part 2, the Regents Review Book Assignment, which go from page 116 to 118 with questions. While I read, I'm going to underline important information and make some text annotations. Seasons. New York and other mid-latitude areas of the Northern Hemisphere experience 4 seasons: winter, spring, summer, and fall. These seasons are distinguished by differences in temperature, moisture, and vegetation. Some land regions near the equator have little seasonal change. There, the intensity of the insolation remains relatively high, and the duration of insolation is about 12 hours per day throughout the year. Direct causes of the seasons. Seasonal changes in temperature, moisture, and other weather conditions result from cyclic variations in the angle of incidence and the intensity and duration of insolation that occur during the year. Generally, the seasons follow the north-south shift in the direct rays of insolation. This shift, caused by the tilt of the Earth's axis, occurs between 23.5 north latitude and 23.5 south latitude, as discussed previously. This shifting of the sun's rays results in the seasons being the opposite of each other in the northern and southern hemisphere. Climate zones and their associated wind patterns and surface ocean currents also shift in a north-south pattern. However, this shift lags about a month behind the shift of direct rays of insolation. Figure 6.16 shows the effect of the shifting rays of the sun on the seasonal positions of the wind and moisture belts on Earth. Astronomical causes of the seasons. The variations in insolation that directly cause the seasons are themselves the results of the factors that may be called astronomical or indirect causes of the seasons. These indirect causes of the seasons include the tilt and parallelism of the Earth's axis and Earth's revolution around the sun. Tilt of the Earth's axis. As shown in figure 6.17, Earth's rotational axis is tilted at 23.5 degrees with respect to the line of perpendicular to the plane of its orbit of the sun. This tilt, coupled with the other areas described here, means the perpendicular insolation from the sun shifts between 23.5 degrees north and 23.5 degrees south. Latitudes. If the tilt of the Earth's axis were greater, perpendicular insolation would reach farther north and south, resulting in generally warmer summers and colder winters for much of Earth. If the tilt of Earth's axis were less than 23.5, then perpendicular insolation would not shift as much. As a result, seasonal effects would be less pronounced. There would be cooler summers and warmer winters. Parallelism of Earth's axis. Regardless of the position of Earth in its orbit, Earth's axis always points the same direction in space. The north end of Earth's axis, the North Pole, always points to the present-day North Star. So, North Pole points to the, I'm going to make a star, not a very good one, and I'll put, North Star there. Figure 6.17 shows that an Earth orbits the sun at the position its axis at a given time is always parallel to its position at any other time. This condition is also called parallelism. Revolution of Earth around the sun. As Earth revolves around the sun, the direction of Earth's axis with respect to the sun varies because of its tilt and parallelism. For example, on June 21st, the North Pole is inclined toward the sun at an angle of 23.5 degrees from perpendicular. On December 21st, the North Pole is inclined away from the sun at this angle. On March 21st and September 23rd, the axis is still inclined 23.5 degrees from the perpendicular, but neither toward nor away from the sun. This cycle of variations causes variations in angle of incidence and duration of insolation throughout the year and results in seasonal changes. Small seasonal effect of Earth's elliptical orbit. Because of Earth's slightly elliptical orbit, there is a variation in distance between Earth and the sun as Earth revolves around the sun. The small changes in distance between Earth and the sun during the year are too small to have significant effect on the seasons. For example, winter in the northern hemisphere occurs at the time when Earth is actually nearest the sun. Winter, underline that. Earth as a whole receives about 7% more energy than its closest to the sun, and it does when it is farther away. This 7% difference would only be significant if Earth's axis was not tilted at an angle of 23.5 degrees. Now for your review questions. Number 39 on page 119. The factor that contributes most to the seasonal temperature changes during a year in New York State is the changing 1. Speed at which Earth travels in its orbit around the sun. 2. Angle at which sun's rays strike Earth's surface. 3. The distance between Earth and the sun. Or 4. Energy given off by the sun. Number 40. On which two dates could all locations on Earth have equal hours of day and night? 1. September 23rd and December 21st. 2. December 21st and March 21st. 3. March 21st and June 21st. Or 4. March 21st and September 23rd. Number 42. Which point on Earth's surface is receiving the greatest intensity of insolation? A, C, B, or D? Number 44. What position in the following diagram best represents Earth on the first day of summer in the northern hemisphere? 1, 2, 3, or 4. Number 48. Which does not cause the changes of Earth's seasons? 1. Earth's revolution. 2. Inclination of Earth's axis. 3. Variation in the distance to the sun. Or 4. Parallelism of Earth's axis. Page 120, number 8. The seasonal temperature changes in the climate of New York State are most influenced by the changing 1. CO2 content of the air. 2. Angle of incidence at which the sun's rays strike Earth's surface. 3. Distance from the sun to Earth. Or 4. Speed at which Earth revolves around the sun. Number 9. The activity shown in the following diagram was used to test the effect of the angle of incidence on a temperature. A student placed 4 thermometers, A, B, C, and D, on a large globe. The bulb of each thermometer was placed against a black plastic square directly on a line representing latitude. The thermometers were then exposed to direct sunlight for 10 minutes at the angles shown. Which thermometer will show the greatest increase in temperature? A, B, C, or D? Number 14. Earth loses heat energy to outer space mainly by radiation, reflection, convection, or conduction.